So exercise 11.4, identify whether or not the following sequence are geometric. If they are geometric, write down the common ratio and the 8 terms. So we know that the common ratio for GP is the second term divided by the first term, also equal to the third term divided by the second term, and the n term divided by the n minus 1 term. So the Tn is ARn minus 1. Okay. So for A, R1 is 2 divided by 1, that is 2. R2 is 4 divided by 2, also 2. And then the R3 is 6 over 4, that is 3 over 2. So the R1 not equal to R3. Okay. Therefore, it is not a GP. B, R1 is 4 over negative 1, that is negative 4. R2 equal to negative 4, 16 over 4, negative 4. R3, 64 over negative 16, that is negative 4. So R1 equal to R2 equal to R3 equal to negative 4. Therefore, it is a geometry progression with the R equal to negative 4. So the 8 terms, so T8, so the A here is this. So we have the negative 1 and then negative 4 to the power 8 minus 1. So we have the negative 1 multiply with the negative 4 to the power of 7. So 16384. So it's 16384. Okay, so for question C here, the R1 is 27 over 81. It's 1 over 3. R2, 9 over 27, 1 over 3. R3, 3 over 9, also 1 over 3. So the R1 equal to R2 equal to R3 is 1 over 3. Therefore, it is a GP with the R is 1 over 3 and the A is actually 81. Okay, so we want to find the 8th term, the 81, 1 over 3, power 8 minus 1. So we have the 81 multiply 1 over 3 to the power of 7. So it will be 1 over 27. Okay, so uh, this one is very obvious lah. Plus 1 plus 2 plus 3. Okay, so the R1, so this is not a GP. So the R1 is 3 over 11 divided by 2 over 11, then it's 3 over 2. R2 is 5 over 11 divided by 3 over 11 is 5 over 3. R1 not equal to R2, okay, therefore it is not a geometry progression. So E, the R1 is 0.4 over 2, so it's 0.2. R2 is 0.08 divided by 0.4, okay, then it's 0.2. Okay, so 0.08 divided by 0.4, 1 over 5. Okay, and then R3 is 0.16 divided by 0.08, then this is 2. Okay, 0.16 divided by 0.08, that is 2. So the R1 not equal to R3, so this is not a GP. Okay, F, the R1 is 5 over negative 5, that is negative 1. R2 is negative 5 over 5, is negative 1. R3 is 5 over negative 5, that is negative 1. So R1 equal to R2 equal to R3 equal to negative 1. Therefore, it is a GP with the R equal to negative 1. And the 8th term, this is the A, will be negative 5 and then negative 1, 8 power negative 1. So this is 5. So negative 5, 5, negative 5, 5, negative 5, 5, negative 5, 5. So we know that the odd terms is negative 5 and the even terms is 5. Okay, so I checked with the Wikipedia. Okay, the common ratio is positive, then the terms will be all be the same sign as the initial, all positive or all negative. If the ratio is negative, then the term will alternate between positive and negative. If the R is negative, then we have positive, negative, positive, negative, positive, negative. If greater than 1, then will be an exponential growth toward the positive infinity or the negative infinity. Okay, and 1, R can be 1, then the progression is a constant sequence. So 5 times 1, 5. So 5, 5, 5, 5, 5, 5, 5 is actually a geometric progression. Okay, according to this. So 1 and negative 1 can be the geometric progression. So is between negative 1 and 1 but not 0, then there will be an exponential declare towards 0. Then we have a sum to infinity will be the next topic. So negative 1, this case is negative 1. So the absolute value for each term in the sequence is constant and the term alternate in sign. Less than negative 1, for the absolute value, there will be an exponential growth toward infinity due to the alternating sign. Okay. GP with common ratio not equal to negative 1, 1 or 0 show exponential growth or exponential decline. Okay.